Welcome to Coach Taylor's class notes, and today we're going to be talking about congruent triangles and a key theorem within congruent triangles. So, first thing we have to understand is that congruent triangles have the same size and shape. They are identical triangles if they are in fact congruent. So this means that corresponding parts, angles, and sides are congruent. And we're going to talk more about this phrase, corresponding parts, here in a second. So when somebody or something or a problem tells us that triangles are congruent, they write what's called a congruency statement. And so this box right here is our congruency statement for these two triangles for the left. So a congruency statement matches all corresponding angles and sides. And so what that means is that if they put letter A first and letter D first, angle A must match angle D and be congruent and be identical, which means that letter B and letter E, or angle B and angle E, must also be congruent. Same thing for C and F. Sorry, I'm trying to make these look a little pretty. The other thing that it tells us is that the sides are congruent. So if A and B are next to each other, side A and B, and this is a congruent marker, then that means AB must be congruent to DE. So again, there's DE, and that's our congruent marker there. So same thing goes for BC and EF. BC is congruent to EF. And then finally, we know that AC and DF are also congruent. So this congruency statement tells us what the corresponding parts of the triangle are. And if the triangles are congruent, all the corresponding parts are the same. So this gives us a very, very important theorem, and it is our CPCTC theorem. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So let's put this into action and let's make sure that we understand what it's saying, even if we are not given a picture. So if J comes first and P comes first, I know that angle J is congruent to angle P. If K is second and Q is second, I know, let's actually write the letter right. Angle K is congruent to angle Q. And then with L and R, angle L is congruent to angle R. So again, so for sides, they have to be in the same order, just like the angles do. So if side JK, which is the first two letters, remember, we name sides or line segments by putting a line segment over top of them. JK is going to be congruent to the first two letters, which is PQ. Then we go the second two letters, which is KL and QR. So KL is congruent to QR. And then finally, we have JL is congruent to PR. Or we can also write it as LJ is congruent to RP. And again, we could also reverse the order of the two previous ones as long as they are in the same position. So when we talk about another valid congruency statement, we have to keep in mind that the same parts must be congruent to the same ones. So we need to put our letters in a different order, but J and P still have to be in the same spot, K and Q still have to be in the same spot, and L and R have to be in the same spot. So one of the easiest ways to do this is to just reverse the letters. triangle LKJ is congruent to triangle RQP. We could also do this as triangle KJL is congruent to triangle QPR, and there's different variations as well. So I want you to do number 2 on your own, and I want you to go ahead and compare it to the completed notes on Canvas. All right, so now we need to make sure that we can match them up when they give us triangles. So angle K has to be congruent to angle A. P has to be congruent to Y. And then C has to be congruent to M. And again, if they give us triangles, they may not be in the same order. So KP must be congruent to AY. PM must be congruent to YC. And then finally, KM must be congruent to CA. So we can write this as KM. And again, I've got to do the same order. Has to be congruent to AC. CY has to be congruent to MP. And PK has to be congruent to YA. Angle Y is congruent to angle P. K is congruent to angle A. Angle ACY is congruent to KMP. And then these are congruency statements, so we need to match the letters. So if they put M first, we need to put C first. If they put P next, we need to go Y. And if they put K last, we need to go A. For our next one, if they put Y first, we got to go triangle P. A matches up with K, and C matches up with M. All right, so we can use these congruency statements with measurements. So if they tell me that S is congruent to B, and I know that S is 67 degrees, then I know that B is also 67 degrees. If they give me T is matched up with F, I know those two are congruent. Right now, I don't know what either of those are. And if I know that W is congruent to N, then I know that W is 82 degrees. So now we can use a little bit of our math that we learned in our previous set of notes. So if we take 67 plus 82, we get 149. 180 minus 149. 7, carry the 1. We know that T and F are 31 degrees. So then if we're looking at sides, I know that ST is 17, which means BF has to be 17 centimeters because those two sides are congruent. TW is congruent to FN, and if FN is 14 centimeters, then I know that TW is 14 centimeters, which means that WS is congruent to BN at 9 centimeters. And so go ahead and fill in the chart with the measurements of each angles that we have in the triangles. All right, and one real quick thing that we need to talk about with isosceles triangles. So with an isosceles triangle, if the two sides are congruent, I know that the two base angles are also congruent. So that's going to help us figure out our answer. So they gave me the measurement of Y. Y matches up with H. So I know that H is 38 degrees. And so now I know that G and J and Z and X are congruent because I know that they are isosceles triangles. So I need to take 180. I need to subtract 38 because that is the measure of angle H. 2, 4, 142. So I know that G and J combined equal 142. And because I know that G is equal to or the same as J, I'm going to take 142 and I'm going to divide it by 2 because I know those two angles are congruent. So 2 will go into 14, 7, and 2, 1. So I know that G is 71 degrees J is 71 degrees, Z is 71 degrees, and X is 71 degrees. I also know that my long sides are 27 feet, 27 feet, and 27 feet. And then I know that my base side is 18 feet, and so this is 18 feet. So go ahead and fill in the information to the right based on the information of our triangles. All right, so now let's talk about when we add algebra and letters into this. So I know that side UV is the same as TS. So TS is here and UV is there. And one thing that I know about congruent sides is I know that congruent is another word for equal. So if I have 12x minus 7 is congruent to 53, I know that 12x minus 7 is equal to 53. So to solve for x, I go plus 7, and I get 60. I bring down my 12x. I need to divide by 12, and x equals 5. So now I can go and I can look at the next set of sides. Why are you doing this to me? VW and SR. So I know that VW is 57. I know that SR is 5y minus 33. So again, if I know that 57 is congruent to 5y minus 33, I know that congruent means the same thing as equals. So I'm going to add 33 to both sides. 5y, we get a 0, 5, 6, 7, 8. I get 90 equals 5y. Divide by 5, 5 will go into 90 once. I carry over 40, which is 18 equals y. And then our last set of sides, I would always check them just to make sure. UW is congruent to TR. So we have 3z plus 14 equals 50. So subtract 14 from both sides. Why do you hate me, pencil? 3z, 14, that's a 6. I had to carry a 4, 36. Divide by 3, z equals 12. And so that's how we can use our CPCTC theorem to find missing angles and missing sides of congruent triangles.